Hello everyone, welcome back. Let's do a deep dive and open nuts and bolts of Azure Load Balancer to have a better understanding its inner working. Let's do a recap what we had on our previous lab. So my lab was deployed, which was a zonal deployment. So all my these two machines they were part of the zone one. Similarly, this load balancer. So my load balancer is in zone one, my two machines in zone one, hence this is zonal deployment what we had. Azure Load Balancer is basically a pass-through load balancing mechanism. That means the IP packets are forwarded unmodified to the VMs, and there's not going to be any sort of port translation happening in between. What it means, so the lab which we are going to test, I'm going to browse a URL which is going to be based on this load balancer public IP address, and we will use the port 80. And I'm going to browse it from a Windows machine which is also hosted on Azure. So when we create a session, it is going to be like that. It will be directly going to your virtual machine, and that is going to be visible in the connection table of the virtual machine when we see the connection has been established. So what we are going to see now, we will see how this connection is initiated, what are the port number basically it uses from the browser, and then on the virtual machine we are going to see how the connection will look like. Before starting the lab, let's just verify the setting for the session precedence, which is set to the none. You have option to go for client IP and client IP and protocol. None means every time a new request which is going to come from the client, there's going to be a load balancing algorithm which get triggers to choose a desired pool member from the pool. This is the Windows machine which is hosted on Azure Cloud as well, and I'm logged in with the remote desktop connection to public IP address 20.121.59.195. Let's see the private IP address for this machine, which is going to be starting from 10.5.0.6. Keep this IP address handy because we are going to see the number of connections going to open from this machine. So we will match whether this IP is matching or not. Now I'm going to browse load balancer IP address, and we are landing to VM1LB. And at this time, this is going to be the local machine. We can see the status for the connection from here. So I'm going to run a command netstat -a, which is going to tell you that all the connections, those are opened as of now. So you can use a small trick we can find, and you can put the string. So this is the IP address is going to be 172.190. So let's verify whether there's any connection open for this or not. And we can see when you hit it or refresh the page, there's a connection which is opened from 10.5.06. This side is going to be the local, hence this port is going to be the dynamic port, and the port is 54468. Remote is going to be 172, 190, 124, 135, and we are heading the port HTTP because we are browsing on port 80. And state is established, and the reason behind we are seeing this page has been opened. If I'm going to run this command again, is gone. Let me refresh it and keep refreshing this so you can see the different state of the TCP. So as of now, it is established. Now it is in close wait. And once the timeout happens, this connection will be closed. This is still in the closed wait and it's gone. Since the connection is gone, we are not going to see anything on these VMs. So what I will do, The command which I'm going to use here, basically, that is again going to be the netstate -80, and I'm going to do a grep for IP address, which is going to be 20, because this is a public IP address which should appear here. So let's put 20.121, and this should be sufficient. And what do we see? There is a SSH session, and this SSH is coming, and the reason behind I'm doing a SSH to these machines. So once I refresh it now, let me put this command here on second VM as well. This is again the SSH, which is coming from the same public IP address. And now when I'm going to refresh this, it is landing to VM2. So I should see there should be another session. And now we see this is the session. And it is coming from, let me refresh it again, 54483. And that's exactly what we see here, 54483. And once I open another session, let's see what happens. This is also landing to the same page. This is going to the VM2. Let me refresh it again. VM2 LB. And we see there's a connection and it is coming from 54489 this time. That means it's going to be the new session and the port number will get changed. This time we should see 4489. You can do multiple testing from here, and you can also basically go to PowerShell and initiate a connection from here. You can run a command wget, and then you're going to put the same URL here. So it does same thing. It is going to test your connection. So you can do it this testing from your browser, you can do it from the PowerShell. And one more thing you can do here, basically you can go right click and go to the inspect, and under the inspect you can go to the networking tab, and in this networking tab basically, now I need to refresh it. It says recording network activity. You can see there's a connection for this public IP address. I'm not sure why it is still recording. Oh, here you go. And here under the headers, you can see there's a TCP response. So when we are sending a GET, you're going to get the TCP 200 OK. And we initiated a remote IP address, which is going to be 172.190.124.135 on the port 80. And you can also get the preview here. You can get the response. And in the response, so let's take a look on another headers as well. When it is, so it can also detect that this is going to be Apache 2441 Ubuntu. And that's exactly what we are running on remote machine. Host IP is this, and preview response. There's a response. So a lot of TCP stuff, but I just wanted to show you how these connections are going to be formed. Let's now change the setting for the session persistence, and I will make it client IP, and let's try to save it. And we are going to see the same behavior when we're hitting earlier without persistence settings. Connections were either going to the first machine or the second machine, and this time when you have the persistence, it should land to the same machine every time when you open a new connection from the same client. So let's see that. We are back to our Windows machine, which is hosted on Azure Cloud, and let's copy this, and I'm going to open a new tab and try to browse this page. So I'm going to close the old one, and this time we are landing to VM1 LB. And let's see how the connection table look like. The support opened 54786, and since we are going to VM1, we should only see this tab connection here, and we see that we can see 54786. Nothing should be here. Yes. And now let's try to refresh it. So I'm going to refresh it, and I will continue to refresh it, and let's see the behavior. It's not going to VM2. Let's take a look on the table. What do you see? There's a port change. If I continue to refresh it, it's not going to VM2 for sure, but port should get changed here. And why it is getting changed, this refresh behavior. Refreshing doesn't mean that you are going to continue working on the same page. It means you're going to open a new session. When there's a new session, this port gets changed, and you're going to see the same intro here as well. But persistence, it is working because it is expected to see the connection which is coming from this machine. It should only go to one VM because we are using client IP hash algorithm, which is going to be the two tuple algorithm. And once the client IP and destination IP is same, you will end up to the same hashing algorithm. That means a particular VM or virtual machine or the pool member within the pool. So let's do it again. It's not changing, and port should get changed A01, and we should see the same A01. That also changes you. Nothing is changing, not even the port. So there's no natting happening. This is coming unmodified. Let's now take a look on health probes. So while configuring the load balancing rule, we have set up the health probes. And health probes, you can see if you choose LB, go to the health probes. And health probes, we had set up for TCP. Though we had three options, TCP, STTP, STTPS. If you go for TCP, that simply means it is going to do the TCP handshake since in ACK, or you go for the STTP and STTPS, then it is going to be the GET request, and response is going to be the TCP code 200. Let's see the behavior. These probes are not coming from the load balancer, but they are coming from a special IP address, and we are going to see those in connection table. As I mentioned, these health probes are going to come from a special IP address, and that special IP address is going to be 168.63.129.16. They're not generated from load balance itself. And since we have configured only the TCP, then we should see the TCP handshake happening on these servers. So for that, I'm going to use same netstat command, and this time I'm going to grab this IP address. Since my probes are running, I should see the connections. This is coming here. If I do the same thing here, I should see the probes hitting this server as well. 63, 129. And that's exactly what we see. This is the SYN receipt. And the port will keep changing. So if I hit it again, this time we see a different port. So this is a behavior for TCP probes. It just checks your TCP handshake and declares whether your pool member is up or down. Now we can test how these are going to be out of rotation. So this is coming, let me refresh this page. We are landing to LB1, and LB1 is this server. If I shut down the Apache which is running here, once the timeout period determined by the probe is over, my request should go to the LB2. So let me refresh again just to show you this is still landing to the VM1. So I'm going to shut down the Apache server here. Let me go to sudo stop, and let's see the behavior. What happens? It failed. And now probe is going to work in the backend to declare that this server should be out of rotation, and we immediately landed to VM2. And we can still see those probes are coming here. So now if I keep refreshing, it is still going to be LB2. I can make it up, start, and once your services are started, let's try to hit back, and we are going back to VM1 LB1. So that's how this probe works, and we see the SYN ACK TCP handshake here. Let's change these probes to HTTP and see the behavior, how the connection table will look like. Now I'm going to change this probe to HTTP. So you can go to the existing probe, and here what we are mentioning, there's going to be a GET request which is going to go on the port 80. Let's try to save it. This is saved. Now we are going to go back to our lab and see the connection table. Let's try to run the netstat again and see what do we see. We are into root. I can do a copy paste. And look at here, what do we see? We see established. It is coming from the same IP address, and established means it is now doing a probe on port 80, that is going to be higher in the layer. And established means it is able to pull on HTTP. A very common trip for you while doing the troubleshooting for the health probe, you need to make sure this IP is allowed by your network security groups. There is one more setting, enable floating IP address, which is unchecked as of now. So let's try to understand when to enable floating IP address. Azure Load Balancer basically allows you to load balance services on multiple ports, multiple IP addresses, or both. In this scenario, we can see there are two front-end IP addresses, FIP1 and FIP2. The first IP is listening on port 80. Second IP is also listening on port 80. Now for FIP1, the redirection pool is going to be this one. And for second pool, I can create pool like this, and those can be basically mapped. And this is perfectly fine. And this is very, very usual topology what we have seen. The default rule for load balancer is not to reuse your backend ports. And that can be solved with the floating IP address when there is a need, the way you design your application and you want to use your, or you want to basically reuse your backend ports. In another scenario where the floating IP is needed, you might have situation like this. You have your front-end IP address 1, front-end IP address 2. They both are listening on port 80, and the redirection will look like this. This is going to be the first pool. This is going to be the second pool. And in the pool, you can see they are listening on port 80. So they are going to reuse the port 80. That is how this floating IP enablement is needed before you configure this topology. One thing to be noticed at the platform label, basically, Azure Load Balancer always operate in direct server return mode, regardless of whether the floating IP is enabled or not. That simply means the outbound part of the flow is always correctly rewritten to flow directly back to the origin. Thank you for watching, and I will see you in the next section.